Welcome to class, everybody. We're going to be, oh no, we're doing properties of logarithms. Class is sponsored today by Chick-fil-A. Do they have does Chick-fil-A have a saying?
Eat more chicken.
Eat more chicken. Well, the hope is Chick-fil-A finds this out and whoa, I got mentioned, and they give me free Chick-fil-A. All right, let's see if that happens or not. All right, let's move on. So the first part involves a calculator. I'm going to show you how to do this using a calculator, and I'm going to show you how to do it a different way using a calculator. Kind of sounds weird, but there's a purpose to it. Okay, so for this first example right here, I just want you to be familiar with a calculator. Okay, so this is a calculator. If you hit this alpha button, it activates all of the green buttons on here. So they see green text. So if you see up here, there's an F2. So alpha, F2. A menu is going to pop up. Some calculators only have 5 things in the menu. Some have 9. This one happens to have 9 things. But I still want log base. So I'm going to press 5. Or you can scroll down and hit enter. It's not going to matter. And then now you literally just type in the problem. That looks exactly like our problem. Then you hit enter, and kablamo, answer. So I'm going to give you 2 different answers here. Don't be freaked out. So this is going to equal 2.523. Am I freaking out yet? Or 2.524. I'll take either of those. This one is called truncating. It's just when you knock down the third or the fourth decimal place. And then this one's rounded. I will honestly take either one. I don't know what other calculus teachers or pre-calculus teachers are doing. I just do know in calculus they don't care, so I'm going to pass the not caring along to you. So I'm cool with either one of these. Just don't round inappropriately. So if that was really a 3-2 and then you round it up and you're not supposed to, well then yeah, I got to take off. Just giving you a heads up there. So that's the first way to do it. Now back in the day, when I was in school in the early 04s, 05s, our calculators didn't have these fancy buttons. They actually had the same exact buttons, but they didn't have the F1, F2, F3. They didn't have that notation. So we didn't have all this fun notation that you have. So we had to find a different way to plug this in. It's called a change of base. This is the same thing as log 16 divided by log 3. I'm just kind of really quickly going over this because it's kind of not really that important, but your worksheet that you're going to do today will ask you to change it. So watch this. If I type in log, by the way, there's a log button down here near the 4, near the 7 and the 4. So log of 16. Hopefully this is the same thing, because if it's not, I'm going to get fired. Oh, thank God. Whew! I was going to walk out of here. All right, same thing. Or you could do ln. It's not going to matter. Do I get the same thing? Math still works. Woo! You can do either one of those. You can do a regular. This is just the ratio of common logs, and it's a ratio of natural logs. That's all that means. On your worksheet, the first 2 problems would be rewrite as the common ratios, and yeah, that's what that means. So just quick heads up on that. Beyond that, I'm fine with you just using a calculator to evaluate all this stuff. So why don't you try number 2 on your own? You can do it any way, any of the 3 ways I showed you. You can do it the really simple way, or the way that requires a little bit of work. I'm going to call in a random person to see what answer they get. Don't worry, Ollie. You're good for the next couple weeks. Swan, what'd you get for number 2? Log base 5 of 22. Is that correct? I'm not even going to do it myself. I trust you. Watch, it's wrong. No, I think that's right. I trust Swan. Smiley face. Okay, let's go down and talk about these properties with logs. So there's 3 properties you really need to know. By the way, calculator gets put away. That's it. It's done. It's over. Just I'll chuck them up here. I'll catch them all at the same. No, don't do that. Should never throw any calculators ever. No one can hear you. Okay, so properties of logs. There are 3 of them. There's the product property. That's when you have, I don't know, we can call these numbers or variables, whatever's in there that's multiplying. It can be expanded as a plus sign. This property should look kind of sort of familiar. Like if I have, by the way, is this zoomed in enough or do I need to zoom in more? It's fine. You good back there, back corner? We're happy with the zoomage of this? Oh, okay. I mean, like, yes, I can. Is that better? It's too much. Alright, you people whine and complain too much. Okay, so this is the same thing. Like, if I had, I don't know, like 2 to the x times 2 to the y, what would you do for that? 2 to the x plus y? It's like the same thing. Multiplying turns into adding. Multiplying turns into adding. Just make sure that the format's all correct. It shows you the logarithm way and then the natural log way. It doesn't matter. They're the exact same rules. One just happens to have an ln. So the quotient property. So when you're dividing, it turns into a subtraction. Let's see here. If I have a 2 to the x over 2 to the y, what does that equal? It's the same thing. Oh my gosh, it's like it's subtraction, but with exponents. I can't believe these rules repeat themselves. And then the power property. That's when you take the power up top, and then you can put it right out in front. Yeah, I don't have no cute thing to do for that one for exponentials. This is the property. Actually, there's a proof for this. It's in calculus, so if there's another proof, I just don't know about it. So don't worry about it. It's not proofs. No, it's like, I don't really care. Just know what they do. Now, how hard is it to remember the word product for multiplication or quotient for division? Okay. You really need to pay attention. This is start tripping some people up. Write each logarithm as a term of an ln2 and ln5. So we're going to be given numbers, whether they're products or quotients or powers or whatever, and you need to split them up so that they become ln's of 2's and ln's of 5's. There might be a couple ln of 2's. There might be no ln of 2's. Okay? We just need to kind of work it out from there. So I want to expand this. So what 2 numbers multiply to give you a 10? Oh my garage. You're going to get 2 times 5. How does that write out now? That's just amazing. Hey, I'm going to do another problem that's not on here real quick to prep you for number 6. Otherwise, you're going to be like very scared. So I'm going to call this like 5B. Can we even see this? It's like the same color as the paper almost. 5B. So, I don't know. I'm going to do ln of 125. How in the world, using 2's and 5's, can you get 125? Okay, 25 times 5. Okay, that's one of the 5's. I need all 5's, though. Okay, so 5 times 5 times 5, that works. Can I also write that as 5 to the third? So this is going to equal ln as 5 to the third. What can I do with that little third power? Put them in front, which is 3 ln of 5. Okay? I'm prepping you for 6, because otherwise for 6, it's a little involved here, so hopefully it's not so involved. So for number 6, how we can make this all into 5's and 2's? Everyone has no clue what to do. Or we don't care. So I heard someone say subtract. Thank you for something. Yes?
Subtract ln of 5 minus, and then you can add ln of 2, like 5 times.
Okay, so I'm going to go... We have an extra step there. What you said is correct. ln of 5 minus ln of 32. 32 can be broken into 2's. How many 2's go into a 32? 16, that's actually correct, but not what I was getting for. 2 to the what gives you 32. 2 to the 5th. So now this is going to write as ln of 5 minus 5 ln of 2. And that's it. Good so far? Questions, comments, concerns? Alright, let's turn it up a notch. Let's find the exact value. So we're going to need some help finding some of these exact values. Or if you know how to do it, then you don't need that much help. We'll find out. So for this one right here, I would automatically rewrite radicals. I would just rewrite it. How do you rewrite the radical of 5th root of 7? 7 to the 1/5. So a real quick side note here. If I had like a 2 to the 1/3, that equals cubed root of 2. Correct? And it works going the other way around. Okay? So if you have a cubed root of 2, you would just get 1/3. Got it? So same thing here. This becomes 7 to the... What rule can we use now to get that 1/5? Yeah, power rule. Move that 1/5 down in front. What's log base 7 of 7? Can we evaluate that?
1.
It's 1. This equals... Well, this little part equals 1, so the entire thing equals 1/5. Is anybody here lost? It's okay to be lost. Ollie, you're lost? Okay, let's go ahead and show this. So, real quick, I'm going to do a little side work here in colored pencil. So, if you ever want to know what ln of 7 is, or log base 7 of 7, it equals question mark, because I don't know what it equals yet. You can always do the loop. So, 7 to the what gives you 7? It's 1. So, this is equal to 1. What if I had log base 7 of 1? This will come up soon. I'm just trying to hit everything that's going to come up today. Well, how do you get 0? Well, it equals question mark, right? So 7 to the what gives you 1? What's the only way to ever get a 1? Is a 0. So in this case, this would equal 0. Are we getting angry over there? You sure? It sounds like a lot of anger. Are you throwing calculators back there? It is not allowed. Good. You should never throw a calculator. Ever. No excuses. Even as a joke to a group of people. Should never do that. Okay. I feel like it's good enough. And then from there, we can kind of just figure it out. All right. Number 8. What can you do for number 8? Fall down? The power rule? Who just said sleep? You are. You people. What's ln of e? Because it has the same base, so it's going to be 3 times 4 times 1, which is 12. Okay, number 9. What's the first thing you do here? Fall down, says Luke. Okay, fine. Let's take that thing and let it fall down. We need to evaluate 3 to the 81. So that's 3 to the what gives you 81? The number, very good. What number is that? 3 to the what power gives you 81? It is a 4. So what's negative 0.2 times 4? Number 10. Two to the what power gives you a negative 16? No? You just say no. You're on your test. No! No, negative exponents only give you reciprocals. They don't make you negative numbers. So can this ever happen?
No.
This is going to be undefined. If you do this in your calculator, it'll say error. Also, you could do this, which, by the way, I'm going to have to rant here for just a quick little moment. Quick rant. Some of you like to write this down as the number 0. In math, we do not do that because in math, that means undefined. So on your math assessments, could you not write down a 0 with a line through it? Because in math, that means undefined. I know that some of your science teachers are like, hey, you need to do that because it doesn't look like an O. Don't do that in math class. Okay? Are we cool on that? Some people do that. Don't do that. Stop doing that. Question. Yes. You still have a negative there. You still can't do anything with it. No matter what, you're going to have a negative. So you're saying change that negative 16 into like a 4 times 4 times negative 1. But you still can't do that last one. You still can't do a log of a negative number. So you're going to get nothing. Number 11. Working back up here. Why don't you try 11 on your own, and then when you're done, try 12 on your own. Let's see how you do on 11 and 12. If you're currently watching the video, you can hit pause. Because I'm going to pause it too. Okay, so you would get 17 for number 11. I should talk more monotone. How do you get that? Well, don't you just put that 12 in front right there? It's like doing 2 separate problems and then adding together the answers. And this is going to give you a 12 because ln of e is 1. And then do the same exact thing for that one. So plus 5 ln of e, and then ln of e is 1, so you're just going to get 5. 12 plus 5 is... Now, I'm going to know if my 2B watches this video because 17 is my favorite number, and I'm going to ask them that right when I see them. And none of you better give them a heads up on that.
Why is it your favorite number?
It just is. Because when I was 17, I noticed I liked the number 17. Just like my 3-year-old, his favorite number was 3. He turned 4, and I guess what his new favorite number is? 4. My 2-year-old doesn't know what numbers are. No favorite number yet. He doesn't have a favorite color, though. His favorite color is blue. My 2-year-old's favorite color is blue. That will be the second question on the test I give you. No, for 2B only, not for you. Okay, so let's go over this one real quick. There's a couple of different ways to do 12. The easiest way to do this is to use our identity. Since we're adding, can't I condense this into one log? Isn't this the same thing as log base 4 of 2 times 32? Which is log base 4 of 64. Which is 3. You also could have figured out that this was 1/2 and then this was 5/2. You could have did that separately. Totally possible. Or you can just do it this way using your log properties. Probably why log properties are easier. Questions, comments, concerns before we turn to the back? Are you going too slow, too fast? Just right? Fast? I can do faster. That's not a problem. Alright, so for number 13, we're going to have we have 3 different going on. It's going to have 3 different log terms, so let's expand. Okay, here we go. I feel like I'm an auctioneer. Oh. Okay, so it says expand. That means I need more logs. We need more logs. That's when we expand. I feel like I'm yelling right now because I have to talk over you. Poor video. It's going to just like loud spurts. Okay, so there are 3 things going on here. There's a 3, an X, and a Y. I'm going to have 3 logs. I'm going to do this in, sometimes it takes 2 steps, sometimes it takes 3 steps. Sometimes it really just happens in 1 step. So I'm going to rewrite this as log 3 plus log X squared plus log Y. All I'm doing is I'm taking all of these imaginary multiplication signs and I'm just using it to expand. So that's why they're all adding data. Any extra steps that need to be done? No. Ali, please enlighten us on the full simplification of this so it is fully expanded. When did you get so smart? When did this happen? Did you get like hit in the head in cricket or something and then all of a sudden it just like changed your brainwaves? He's ignoring me. Yes, if it's fully, I want it fully expanded. It needs to be written like this.
For the x squared, could you not do log x plus log x?
You want to do log x plus log x.
No, I know it's not right.
You could, but it would not be fully simplified. You do expand and simplify at the same time. So I want many, many logs, but every log needs to be simplified as much as it possibly can. So this is the most simplified log x's I could have. Just deal with it. Let's try 14 together, and then we'll start to go from there. Looking at 14, any ideas how to do it? There is going to be some subtraction here. Let's go ahead and do it. Your talking is growing increasingly annoying. You really should stop. Do I need to put sad faces? Pay attention. Okay. Is this fully simplified? No. What else can I do? Doesn't this really equal a 1/2 right there? So what can I do now? Bring the 1/2 to the front and call it a day. There's nothing else you can do. Why don't you give 15 a good old try when you're done, 16 a try. And if you're watching the video, now would be a good time to pause. Alright. Let's come back together. Am I completely done here, or is there more I can do? Why would I combine them? I'm trying to expand. What's log base 6 of 1? It's 0. So this is equal to 0. So this just becomes -3 log base 6 of z. If you can actually evaluate it, you need to evaluate it. Be aware of that. If you can evaluate, you must evaluate. Alright, let's go ahead and do 16. There's two different ways to do it. I don't really care which way you do it. I'm going to do this first. So ln this rewrites as ln of x squared over y cubed, all to the 1/2. So then this can move on in front. 1/2 ln of x squared over y cubed. Are we good so far? Now what? I subtract. What happens to 1/2? Stays in front. I'm going to put it all in little brackets here. So I'm going to get... Can I just like skip a step here and just tell you that? Are we cool with this? It could be parentheses. I mean, okay, no one's really going to care. It just looks more visually pleasing if it's a long thing. Usually I use brackets. It's more pleasing to the eye. This is one perfectly good answer, or you can distribute. If you distribute, what do you get? That's also perfectly good. I'll take either or. I don't really care. Okay, 4 problems left. These don't take so long. We'll try to get this done before that 30-minute mark. We got 5 minutes. What I need to do now is condense. I want 1 log. 1 log and 1 log only. So for 17, how many logs do I have? 2. And I want to get just 1. So now we're gonna go backwards here. So the first thing I usually do for this is see if I can apply the power rule. Okay? So on 17, I can apply the power rule 2 times. Where do you see it?
Move the 1/3 and the 5.
And now we can do what? Put them together, multiply them. Voila, that's it. That is condensed. Questions about this? Some people have questions for this, so they're like, oh, can we do this or that? And I just have to tell you no. But sometimes there's good questions, good discussion. I like discussion. Yes?
So instead of x to the 1/3, if you put the cube root of x, is that wrong?
That is not wrong. That's a great option. You can also put this as your answer. These are the same things. I'll take either or. So typically in math, if a question has something in root form and your answer has a root, it needs to be in root form. But this doesn't have any roots in it, so that's why I don't really care. Number 18. What's the first thing I'm going to do? So ln of x minus 4 to the 4th minus ln of x squared, which becomes... Is there anything else I can do?
Nope.
Can you cancel out this 4 and that 2? No! They're different bases. This base is an x minus 4. This base is an x. You cannot cancel out those exponents. Good try, though. But really, not a good try. That was a terrible try. Who would do such a thing? 19 and 20. Give it yourself a good try there, and we'll come back together in just a moment and finish up these notes. Please pause the video. And we're back. Okay, so I did the work here for 19. Go ahead and check it out. Make sure that it matches you. I did hear a comment. Can you distribute this x if you want? You could. You'll get a correct answer. You don't have to. So why would you? What if you do it wrong? Then it's wrong. You don't have to. So just kind of leave it. Do I need to zoom in more? Yes. Like right here? Like this? This is not condensed enough. Alright, and then the last one. Shh, we're almost done. We're almost done. We're almost done. There's the last one here. A couple different options here. You can just work inside the parentheses first, or you can distribute. It's not going to matter which one you want to do first. Distributing might be a little bit easier. Why don't we go ahead and distribute? Okay? Distribute the 1/2 to the 2 becomes a 1. I'll just ignore it. Don't need anything in front. Watch me go real quick on this one. So this is going to give you log base 4 of x plus 1 to the 1/2, x minus 1, and then x to the 6th. That's really about it. You can rewrite it a little differently if you want with that exponent, making that a square root. I like to put my just plain old x's in front. Why do I do that? I have OCD. I'll take any 2 of these answers. Doesn't really matter. What if? I like these what ifs.
brackets first, and then when you did. Okay.
You get that, right?
And then you put the 1/2 back, but you put it as a square root.
Over all of it?
Yeah.
That's fine.
Okay.
I mean, I'm not here to be very nitpicky.
Alright.
I don't really care. I am over the 30-minute mark.
Just barely.
Not bad. Wasn't for your comment. Yeah, you. That's fine. It's all your fault.
Maybe you should have talked about your favorite number.
Which is
17.
17. Why is it 17?
I don't remember.
Because when I was 17, I decided I'm done picking favorite numbers. 17's prime. I like prime numbers. My second favorite number is... Well, here we go. Next trivia. They're all probably done watching it by now. All right, let's just keep this rolling. They'll be like, whoa, what a long video. My second favorite number is another prime number. 81 is not prime. Not 83. Not 3. Somebody said it. What? What 3? 23 is correct. Because my wife's favorite number is actually a perfect number. So 23 is the sum of my favorite number and her favorite number. 6 is a perfect number. Look at how much math you're getting just from this at the end of the video. A perfect number is when you can take the factors of it and it adds up to that number. Right? So the factor, you have to exclude the number itself because you obviously can't add it itself. It'll never work. So the factors of 6 are 1, 2, and 3, excluding the 6 itself. Add them up, get 6. The next time it happens is 28. 1, 2, 7, 14. There's a 4 and a 7 in there. Oh, there's a 4 in there somewhere. 1, 2, 4, 7, 14. Yeah, add all those up. It's 28. The number after that, I don't know. It's pretty big. It's like 3 digits, maybe it's 4 digits. I don't know. Kane, what's the next perfect number? Who just said your mom? What's the next perfect number? Your mom. Ah! And let's end on that.